All right, the easiest of them all. So this guy, what do we have? This I will not do a lot of explanations. So the figure 3 shows the damping mechanism of a dump truck, which the bucket QRST is pivoted to the main frame at C. All right, so this bucket is pivoted at this point. The bucket is supported by link AD and DEF. So AD and DEF, they are supporting the bucket. Okay, and a hydraulic actuator BG, this hydraulic actuator. If the bucket rotates 15 degrees clockwise at about point C, so this rotates 15 degrees clockwise about point C, draw the displacement diagram and indicate position 2 of D, E, F, and G. So that's what we're going to do. Now, the point F is on the bucket. So if the bucket rotates 15 degrees, the point F will also rotate 15 degrees. So what we want is a line joining F towards C so that we can be able to measure our 15 degrees properly. So to measure the 15 degrees, you align the center here to the point of rotation, and then you align the line here with the line that is rotating. So that's what we're going to do. So when I do that, like this, right? So 15 degrees will be here. Okay. So you come to this point here, and then you do that. Okay, so another thing you know is that, hey, this hasn't been of use. So you know that the point F rotate about C, right? So what we're saying is F has rotated with the bucket 15 degrees, but we don't know the exact point on that line that is located. But we know that F2 is going to rotate about C at a constant radius. So if you pick that constant radius from A to F, so if you use this path, it's rotating about C. So they are crossing at this point. So this is where F2 will be. Okay, so now we know F2. Now what we know next is F. So we don't go to E yet because E is not rotating about B with a constant radius. Okay, so you skip E, come to D. So now you know that F and D is also going to have a fixed distance, right? Because it's a rigid link. Okay, so you come and stand at F2, then you make an arc. Again, D rotate about E at a fixed length. So you come and stand here, put this one here, and then you create an arc. So these people are meeting here. So that will be your what? D2. Now you know DF are on a certain line. So you just join D2 to what? F2. Like that. Good. Then probably D1 joins to E. So just rotate, doesn't remove. So this one too will join to what? E. Like that. Okay, so what we know is E2 must be on this line because this link will always contain E. So we just measure D to E, E to D, or E to F, anyone you want. I want E to D. Right. So what it means is this is the length that D will have with E all the time. So just take that length and then you cut on this line. So where you cut is where your E2 is going to be. Again, don't go and do arc because the distance from E1 to B is not fixed. All right. So if your E is here, then now you can join E to what? B, because the hydraulic actuator will always be in line like that. So after getting this, you know G, the G there, what is the barrel of the hydraulic actuator, and the base, no, it's always going to what, have a fixed distance about B when it is rotating. So put your pin here, you put your compass here, and then you cut. Where you cut is going to be your what? G2. Easy like that. Easy like that. So we are done. Soft. And yes, if you are not coming for the tutorials, do that and come. Nobody can do this for you. All right. I am the master strategist for these courses. Yes. You can join our one-on-one sessions or the group sessions. I recommend the group sessions. The one-on-one, you become plenty, I'll get tired easily. So join the group sessions every weekend, 4 hours every weekend. If you don't know what you're doing with your life with this course, come and join Harcourt tutorials this weekend. It's easy 300 cities. Don't go and tell me that semester night then you know, yeah. So I'll be looking forward to seeing you this weekend. Now let's continue. We are done with the displacement diagram, and you are supposed to, from the diagram, knowing that BG is 1500 or 1500 millimeters, determine the extension of the actuator, the angular rotation of the link AD, and indicate with arrow, and angular rotation of the actuator BG, and indicate with arrow the direction. So easy like that. So I'm going to measure the extension of BG. So the extension, yes, you see, normally when they say extension actuated, they're talking about where it has extended to. So it's measured from here to here. But what they are talking about right now, is how much this one has extended, which is the stroke, yeah, of the hydraulic actuator. So I'm going to measure BE1, BE1. So yes, the first thing is what extension, right? So extension will be equal to BE2 minus BE1. So BE2, let's measure that guy first. BE2 is 7.2. 7.2. So 7.2 minus, and then this guy 7. So that is 0.2 centimeters. Right. But the question said that a certain measurement on the diagram, which is BG. BG here. BG was 4.7, right? BG, which is 4.7 on the paper here, is equal to 1500 in the actual design. So this 0.2, what will it be? So 0.2 on this will be equal to what? All right. Again, my x is anything I'm looking for. So I'm going to have 1500 times 0.2 divided by 4.7. So I have x to be 63.83 millimeters, right? Which is same as 0.064 meters. Any of them will do for you. Next is the angular rotation of link AD. Right, so you want angular rotation, right? Now AD, you need to have a line joining A and D. Okay, so maybe some nice line so that I can do your measurements. So like I said, AD is rotating about what? A. So your center here aligns with the fixed point, and then the line here aligns with the line that is rotating. So now you see, if you put this one here, it covers everything. You can't see what you are measuring, right? So you can extend one of them. You can extend the position 2 with a very thin line. I get it. Don't do it deep. It's not part of the work. So put this one here, put this one here, like that. So that will be 25.5. All right. So theta, the angular rotation of what's BD is what 25.5 degrees, and it's clockwise. Okay, the next is the angular rotation of the actuator BGE. So BGE is the same problem, right? So you join BE like that, then you stand here, then you measure. Yeah, this one was almost 20 degrees, so like 19.5. No, there's no way this is not going to be 20. So theta B, no, it's not B. Sorry. So this is AD, not BD. AD, theta BGE. That's the angular rotation for the BGE link. It's what 20 degrees, and it's also clockwise. Hooray! We are done with all the assignments. Yes, so if I see good reaction on these videos, that will mean I'm going to do the rest of the assignment for you every week. If you watch and you don't subscribe, you don't share with people, know that I won't do it. Yes, and for those of you waiting for Lamla, I'll be there. Bye bye.